You're watching Telecom TV. I'm Guy Daniels and we are here live with our Q&A session on the practical opportunities for mmWave 5G in Europe. This is your opportunity to ask questions of our guests, and I urge you to please use the submission form on the Telecom TV website. You'll find it just below the player window. So let's meet our guests. Joining us once again are George Tsirtsis, Senior Director Technology at Qualcomm Technologies International, and Nicholas Waegner, Senior Director Program Management at Qualcomm CDMA Technologies. Welcome back, both of you. Now, earlier today, you guided us through a great presentation on mmWave 5G, on the state of mmWave worldwide and the work that is involved with bringing this technology to fruition. We've already started to receive some questions from our audience based on that presentation, so let's get to those first. But meanwhile, for those watching us live, please do submit your questions as soon as possible. Thank you. So first question, George, I think this one's heading your way. What is so special, so different about mmWave? Why are we approaching it as more than just another cellular frequency band?
Oh, thank you, Guy. Yeah, that's a good question. Millimeter wave is special because of the spectrum and bandwidth involved. So when we talk about millimeter wave, we are really talking about 26, 28 gigahertz in Europe and 39 in other places. At this frequency, there is a lot more bandwidth available. So in 4G and 5G and even earlier generations, the bandwidth that we have been being able to use in cellular networks is in the order of 5, 10, 20 megahertz. Then with carrier aggregation in LTE, there were a few multiples of that. And now with 5G in sub-6 was the first time that we saw a band allocation of 50, 60, up to 100 megahertz. And that gives obviously a lot more capacity to the systems. In millimeter wave, we are starting from 100 megahertz, the smallest possible allocations, and there are 200, 400, and 800 megahertz. So for example, in Italy, operators have 200 megahertz each, and they can go up to 1 gigahertz with a certain kind of what they call club use in Italy. In Finland, the operators were just allocated 800 megahertz each. And that goes directly to capacity, very high speeds, but also affects many other things, including latency, because the frequencies at 26 gigahertz, 28 gigahertz have much shorter wavelength, and so the bit information can be encoded in much shorter time frame, and that helps to reduce latency quite a lot. So this is a lot of the promise behind low latency communications comes from this kind of capability. And also from the same fact that the wavelength is shorter, we have much smaller antenna elements. So we can pack more antennas in a smaller form factor antenna modules and antennas, both on the device and the network side. So all these things create a lot of differences, a lot of advantages that are going to be exploited over the next years.
Great, thanks, George. And I think we've got a question about antennas coming up soon. We'll ask that one in a moment. But first, Nicholas, I'd like to ask you, to achieve the promise of millimeter wave requires a lot of work. Can you summarize the most challenging technical aspects of developing commercial millimeter wave solutions?
Yes, Guy, thank you. Indeed, there's a lot of work that has gone into to making millimeter wave a reality in mobile systems. And we as Qualcomm have contributed a lot to that, particularly to the mobilization of millimeter wave. And that, I think, is a major difference, as we showed in the presentations, that we're actually talking about a true mobile technology, miniaturized to the extent that it can be incorporated into smartphones, no different to the smartphones at lower wavelengths. So I think this simplifies and deployment considerably and offers tremendous opportunity, as we've indicated in different scenarios, and that has already been part of a development of an entire ecosystem, which has now found its way into commercial deployments worldwide. We've talked about how mmWave is deployed in North America, in Asia, and now it's also coming to Europe. So these challenges of the past have now been found practical solutions, and those are being deployed. We also talked about applying mmWave to fixed wireless access, and there, of course, we want to achieve a good coverage, an extended coverage, or also coverage within a building as well. So there also solutions have been found, and we talked about the high power CPEs, which are now available to address that challenge as well.
Thank you, Nicholas. A reminder to our audience, please keep sending in your questions. George and Nicholas are here for the next 25 minutes or so to answer your questions on mmWave 5G. So let's take a look at what new questions are coming in. There's a good one here, and it's based on your presentation. George, I think I'll ask this one of you. From your presentation, it would appear that some of what we once considered challenges of mmWave may actually be turned into advantages, such as signal reflections being used to extend indoor coverage within unusually shaped rooms, and limits to wall penetration being useful for secure environments.
Yes, that's true, and we have done a lot of work to what we say is to mobilize mmWave, and a lot of the challenges that were perceived at the beginning were about that. mmWave was used for a long time, of course, for as a fixed technology, and it was considered very challenging to create a mobile system out of mmWave, primarily because of the directionality of it, the fact that you cannot create a large coverage with a wide beam so easily for these kinds of reasons. So we over the last couple of years we have now proven it's kind of normal part of the literature that mmWave can be used in mobile systems, and indeed in that work, not only we learn how to create beams that are focusing on specific devices, move around with the user, and can maintain that connection, but also how to utilize reflections that are naturally happening, so that we have signal from multiple paths. We can switch to the right, to the best signal that is possible, not only direct in a direct path between the device and the antenna, but also indirectly. And in Nick's presentation, there were some results from an in-building, for example, where we saw that an antenna that was facing a certain way was kind of creating a signal that was reflected around and was providing coverage even behind the antenna. So these are ways that we have learned how to use the technology, and also other limitations that are really things like mmWave in practice will not go through brick walls. That's how it is at this frequency, and that can be an advantage also in some cases. For example, again, when you think about indoors, if you want the best possible performance in a factory floor or even in a home office, then you can have a mmWave system that provides you full, let's say, 100 megahertz spectrum dedicated for that one location or room. And there is very little, next to zero interference to what happens to the next room. So, and this is very unusual. So in the most dense cases where we have, for example, Wi-Fi in a dense urban environment with many flats in a building, for example, we have all sorts of interference, right? And at the limit, it kind of has problem working. With millimeter wave, you deploy it in one room. The next room, you can redeploy exactly the same capacity without any interference from the room next door. And again, in certain environments, that can be a big advantage. So we will, explore all of these possibilities.
Fascinating. And I think we've got a related question, really. Nicholas, I'm going to ask this one of you. Still, when we're looking at millimeter wave indoors, siting and planning indoors looks to be very difficult and work intensive. Could this be a barrier to millimeter wave adoption?
I don't believe so, Guy. I think as we showed him the example that we gave of deployment, for instance, in an enterprise environment, we can actually leverage the existing infrastructure, the existing Wi-Fi access points as locations for deploying millimeter wave, and these provide a basis for excellent coverage within that same environment. So in terms of that comparison, or the opportunity to complement Wi-Fi with millimeter wave, that is given. Also, in terms of planning, if we compare planning of millimeter wave compared to classical cellular deployments, we can actually leverage the same tools, the same approach and methodologies. Of course, some understanding, some exploration, model tuning of millimeter wave in these new environments is required in order to increase the accuracy of the prediction. But that's already, given the commercial tools currently available, we already get a very good base for such deployments. So in terms of that methodology, we can use the same. And as we said, millimeter wave can be viewed as a complement to existing systems, whether they be cellular 4G or even 5G in sub-6 spectrum. So therefore, we can use millimeter wave where it's most needed, where that capacity is required, where the use case also might require it, and then complement that with the existing deployments in other areas, for instance, of an environment which might not need that. So I would say it's we can play on all these technologies in order to provide the optimal solution.
Great. Question in here that says, the dramatic increase in speed is all well and good, but what services really do need or can take advantage of gigabit plus speeds, especially when it comes to consumer users? Do we know yet what these services are that might take advantage of millimeter wave? George, can I ask you that?
Yeah. It's a great question. The gigabit speeds are indeed very, very impressive. And what I said also in the presentation at the beginning was that behind the gigabit speeds, there is capacity and low latency. And it's a combination of all these three factors that are impressive and actually what create immediate value, but also the long-term potential. So it is true that today you don't need a 2 gigabit speed on your smartphone, but you do need hundreds of megabits. And you do actually, when you're lucky in the best LTE networks, you do get those. And that's when things work at their best in LTE networks, when you have actually access to hundreds of megabits per second or at least many tens of megabits per second. So when you want to download a large movie or play a very intensive game, there is quite a lot of bandwidth involved, and the better speed you have, the more quickly things happen. But things that, what affects very much your experience is how many other people are trying to do the same thing at the same time. And this is where an LTE network will suffer very quickly. If you are in a very dense environment with many users trying to participate in the network, when with 5G things get better, even with sub-6 technology. But with millimeter wave, it really comes to a head. So when you are in the busiest part of the town center, when you are in a big stadium or a venue or a central hub of some form where you have so many users are trying to use the network, that's where millimeter wave will sustain your best performance, the best performance that you can see in a 4G network. It will be sustained across many users in the busiest place. Right, so that's what gives the immediate benefit rather than the gigabit speeds themselves. But the gigabit speeds is what will allow the new generation of applications to evolve. And these things don't happen overnight, but over time, you know also from everybody's experience that all the applications that were written, let's say 10 years ago, were written for like much lower bandwidths. So today's applications would not have even worked 10 years ago in the networks, and the same trend will continue. Applications will utilize the capacity and the peak throughputs, and gradually will become more and more normal and expected by the networks. So this is a process, but the important thing is that you get immediate benefits in busy scenarios, and then over time, of course, there will be many others. And that is in the consumer side. Of course, in enterprise and industrial space, the situation is different, because then, especially in industrial, you have specialized applications anyway, which can actually leverage the capacity and the throughputs from scratch, from the beginning. So it varies, of course, on segment as well.
Great, thank you very much for that. We've got a question in about fixed wireless access here. Nicholas, I might ask you this one to start with. The question is, would you say the performance of millimeter wave is as good as fiber in terms of residential broadband connectivity?
As we showed in these examples of applications of millimeter wave, I think millimeter wave is an enabler as a complement, as a rapid way of deploying such services in environments which might otherwise not benefit from fiber connectivity for different reasons, for economic reasons, or for practical purposes. So we see even in Europe, many countries, many areas still, the fiber deployment still needs some time, and therefore millimeter wave would provide a great opportunity to provide those services in a shorter space of time than otherwise would be possible. So that's for say in urban environments, and then that's even more the case in more rural areas where it's from the speed and the economic standpoint, this is a great enabler. And given the bandwidth that we have available, as we continue to say, so that we're talking about bandwidths of hundreds of megahertz, as you saw from the coverage studies that we have, we can also offer with millimeter wave fixed wireless access speeds of in excess of 100, 200 megabits per second at considerable ranges from the cell site. So these are real opportunities to complement other forms of access.
Thanks. There's a technology choice question coming in here. Choose who to answer this question, but this is, why would stadium or building owners, or indeed enterprises, why would they go for millimeter wave instead of, say, Wi-Fi 6? Who would like to address that one? George?
Yeah, I can start. Yeah, and Nick, please add if needed. So, we actually see Wi-Fi 6 and 5G in general, millimeter wave in particular, as complementary technologies. It's not competing technologies as such. There are many reasons to look at them this way, from the variety of, especially in public areas where it's not an industry floor where you deploy a specific technology for a specific region, but a public space where you have all kinds of devices in a kind of essentially uncontrolled manner. 5G and Wi-Fi will be complementing each other. And the reason is very simple, that of course there is a very large variety of devices, and you want to give the best connectivity experience to every user, whether they have an older device, newer device, one that happens to only have Wi-Fi or cellular or a mix. So I think in practice and for a long time, the discussion will be about having both of them, not one versus the other.
Nicholas, is that the case? It's complementary.
Yes, I completely concur with George's statement. A stadium is an environment where there's a huge capacity demand. We talked about the demand of the single user maybe being several hundred megabits per second, but you have to consider the stadiums that we gave as examples of up to 100,000 spectators in the same area. So therefore, we need to provide capacity. We need to provide also this user experience, which may also evolve over time. So and millimeter wave, as we've shown, is deployed and is able to in such an interference and limited environment provide a very effective and very efficient way of delivering that capacity in that environment.
Thanks. Now we've got a future-looking question coming up here. Are there other devices apart from smartphones, laptops and hotspots that can harness millimeter wave at present? And if not, what are the next range of devices that we'll see that will be able to use this technology?
Maybe I'll take this one, Guy. Yes, so in fact, it is quite impressive that we have already smartphones and CPEs, hotspots, and laptops. Laptops is a new thing in cellular, although you could buy a special module for laptops in LTE days. That was not very common, and I think it's now coming to maturity, the idea of having a cellular connected laptop. So we'll see a lot more of those, and definitely Qualcomm is investing a lot with Windows on Snapdragon, where this new breed of laptops are leveraging our Snapdragon processor, so ARM architecture, to run Windows on. In addition, of course, to other types of laptops that can utilize 5G modules. So the laptop itself is a very 5G device, and it's going to be a key going forward in expansion of 5G in other verticals in addition to smartphones. Beyond that, though, we have many other things that are coming on 5G in terms of devices. So first of all, we already have in the market, and I think I showed in one of the slides with all the devices, we have 5G modules incorporating both sub-6 and mmWave. And those are very important in connecting non-smartphone devices to cellular networks. They use standard interfaces like M.2, but they come also in many other form factors. This is the IoT space, the Internet of Things space, which is in itself vast and complicated. But these kind of standardized modules already provide a solution to these kinds of devices. So AGVs, for example, autonomous vehicles, and robotics. Many of these industrial sectors are looking at these M.2 modules, and of course then fully customized modules. So that's one sector. Then the other that is going to be quite fascinating to see evolving has to do with the mixed reality. As you know, Qualcomm is very much involved in mixed reality, AR, VR. I think it's hard these days to find a VR device that doesn't incorporate Qualcomm technology in it. And the opportunity there is to create connected mixed reality headsets, especially as we move to augmented reality glasses, which can be more easily be worn outdoors and while you move around. And we have already a very important product in this category. We call it Snapdragon XR2. And this is 5G enabled. So we are already working with device partners for the first generation of 5G connected devices in 2021 timeframe. In the meantime, what is also interesting is that this kind of XR devices, which again will come in many different form factors, some of them will be connecting to your smartphone. So you will be getting an accessory to your smartphone that will enable you to do VR or AR by wearing that set of glasses or headset, and then the communication and part of the processing or a lot of the processing comes either from the smartphone itself or some combination of the smartphone, the cloud, and the compute capability of the device itself. So there are many very interesting devices that will be coming online in the next year and more, I think. So it's a very interesting space to watch.
Great. I'm aware of the time, so I'm trying to combine a couple of questions that are coming in here. There are two or three that are quite related. Let me try and put these into one. As millimeter wave technology matures, might we see fewer antennas, transmitter sites needed, or are we likely to see an increase in these sites and antennas?
I think that will depend on the scenarios we showed. Actually, in order to deliver customer experience in an environment which requires high capacity, and we gave many of those examples of high footfall scenarios. It is true that we can actually, because of the bandwidth we have available, actually reduce the number of sites that we need to provide the same capacity in such an area. So in that case, indeed, there is an opportunity there. In the similarly, maybe in offering high capacity in outdoor areas, in areas of again of dense usage, city centers, squares. We could also provide that with with a more limited number of sites.
Great. And a question just coming in about integrated access backhaul, which was covered in your presentation as well. Here comes a question. A common understanding is sites for millimeter wave will most likely follow a small cell type deployment scenario, but using IAB could help to minimize the overall costs and reduce the time to market. So the question is, do either of you have any feedback on IAB and its readiness from standards and ecosystem perspective?
Let me start on that, and Nick, please add. The IAB is actually one part of a wide range of options in terms of providing wireless backhaul. So the objective of IAB is to remove the requirement for a physical fiber at the site of the G node B, whether it's sub-6 or millimeter wave in this discussion. So the difference is that IAB is all about what's called integrated access backhaul. It's reusing the frequency that you have for access, let's say 26 gigahertz millimeter wave, reuses that frequency for the backhaul. And in that case, because millimeter wave is very directional, you can create very good isolation between the access part and the backhaul part. So it's a very compelling technology for this for the wireless solution. But in terms of providing wireless access to sites, whether are macro or small sites, there are other technologies like 60 gigahertz. There are traditional point-to-point millimeter wave links that you can create. So there is a variety of solutions there, and indeed, all of these things help a lot in deployment of sites. As we go up in the in frequencies, the network tends to become more dense, or needs to be more dense to provide the best performance. And having this capability of using wireless technology for backhaul instead of always having fiber available is increases the flexibility and makes it easier and cheaper to deploy in certain cases. So it's all in the toolbox, and it helps with certain deployment scenarios.
Great, thanks, George. I think we can squeeze in a couple more questions before we finish. There's one here, again, it's about antennas. It's a technology-based question. How much of the work in developing millimeter wave is constrained by antenna and base station design? Do we need to see an evolutionary shift here, such as the new R&D work that's been going on with large intelligent surfaces? Do we need more advancement in antenna and base station design?
Okay, interesting question. So we always need more, Guy. The more, the better of new technologies, and there will always be new solutions and more innovative solutions, and that's how technology works. However, I don't think we need anything fundamental for to deploy millimeter wave. In fact, the technology that is available today has a long way of being utilized in terms of antennas. The big shift with millimeter wave antenna design has been the fact that we can, as I said earlier, we can create the antennas themselves are much smaller in size, and that creates new form factor antenna designs. You can pack a lot more antennas in very small form factor, lighter devices that they just transform the way that networks are deployed just by themselves, without necessarily having antennas in the walls and like micro antennas that are spread out in kind of new innovative ways, which are all technologies that are being under research and development. And I think we will see them coming as well in the field over the years. But I don't think there is a fundamental shift in antenna technology that is required for millimeter wave. We have what we need.
Great. And I think this is going to be the final question. Let me put it to both of you. It's about the limits of millimeter wave technology. The question is, are we at the early stages of exploring the high frequency ranges with much more in store and even higher frequencies than millimeter wave? Or are there real world limitations on just how far we can go? Nicholas, could I ask you that first?
Well, I think we're at the beginning of this story of millimeter wave. We have deployments now in 28 gigahertz, 26 here in Europe, 39 gigahertz in North America, and there are spectrum above at higher ranges also being considered. What we're looking for is that bandwidth that we need for future applications, and that's to be found in these higher spectrum ranges. So as we've mastered millimeter wave in these first pioneer bands, we're finding solutions for those beyond. But maybe George wants to comment.
Yes, thanks. I think I agree with Nick. We're at the beginning. We have made a big start in cellular technology by now being able to commercialize millimeter wave in certain bands, say 26, 28, 39. These are already commercialized in mobile systems, in fixed wireless access systems, and we see now getting into enterprise industrial. So in terms of use cases, we are beginning to see a variation here on the cellular theme with verticals. In terms of frequencies, the standards will continue to evolve. 3GPP is working. We're just deploying release 15 3GPP. Release 16 is defined. Release 17 is coming, which introduces more and more technology, new frequencies as well, even further up from 39 gigahertz. So there is plenty of room. In fact, this is part of the fascination with 3GPP, and the excitement around it is that we're just now, whatever you have seen around 3GPP is just the first generation of it. And we have like at least a decade of evolution on 3GPP, which we will see a lot more capabilities, a lot more nuance in customizing the systems for specific technologies and making more capabilities available to the general user. And cellular is is one of the big platforms in the world, and the 5G infrastructure will become the platform over which many new things will be deployed. Takes time, but benefits are immediate, and then new capabilities gradually sneak up on us, and before you know it, you will not be able to imagine yourself without a 5G capability phone or home connectivity, and also millimeter wave. So it's going to be very, very exciting to see what happens in the next few years.
Exciting times indeed. We look forward to continuing this discussion because it's evolving so fast. But that really is all the time we have for you today. Thank you, George and Nicholas. Great insight into millimeter wave 5G and Qualcomm's activities, and we appreciate you answering so many questions. A big thank you also to you, our audience, for watching this live broadcast and for submitting your questions. If you have any further questions or points you wish to raise, then please get in touch with us and we'll pass them on to George and Nicholas. Goodbye for now, and we hope to see you again very soon.